Okay, this is the video for the practice test for Chapter 12 in Pre-Calculus. We're going to be doing numbers 1 through 19, and that has to do with section 12.1. Okay, and problem number 1, it says write out the first 5 terms of the sequence, and the sequence is defined like this: n squared minus n, so pretty simple. We're going to find the very first term denoted by this subscript 1, which means if we're putting 1 in for n here, we're also putting it in for n on the right side of the formula. Okay, so this is just going to be 1 minus 1, 0. That's the first term. Okay, term number 2, we're using 2 for n, and therefore we're using 2 for n on the right side. So this is going to be 4 minus 2 is equal to 2. Term number 3. 3 squared minus 3, which would be 9 minus 3, which would be 6. Term number 4 would be 4 squared. I just keep following this formula right here. Minus 4 once again. This would be 16 minus 4, which is 12. Okay, and then the last term, fifth term, is 5 squared minus 5. And that's going to be 25 minus 5 is 20. So listing the first 5 terms of the sequence, it would be 0, 2, 6, 12, and 20. Okay, moving to problem number 2. In problem number 2, again, you're listing the first 5 terms of the sequence. In fact, you're doing that but using the same instructions for numbers 1, 2, and 3. So in number 2, the sequence is defined as 2 raised to a power of n. So when you find the first term, it would be 2 to the 1 power of 1, or just 2. When you find term 2 of the sequence, it would be 2 to a power of 2, or 4. When you find the third term, it would be 2 raised to a power of 3. So again, whatever you're using for n here, you are also using for n on the right side where the formula is. 2 to the third is 8. 2 times 2 times 2. Fourth term would be 2 to the fourth, which is 2 times 2 times 2, but you can just use the power key. 2 times 2 times 2 times 2 times 2, 4 times. Hope I said that 4 times. So 16. And then last term would be 2 to the fifth, which is just 32. Okay, so listing the terms of the sequence, it would be 2, 4, 8, 16, and 32. Okay, moving on to 3, where we have a formula that involves a fraction. So the sequence C sub n is defined as 4 times n plus 2 over 4 times n. And here, you're going to want to get your calculator involved just to help you with the fractions. Okay, so when we go to find C sub 1, just as we've done in numbers 1 and 2, whatever you call n on this side, that is what you're using for n on the right side as well. So it's 4 times 1 plus 2 over 4 times 1. Plugging in a 1 everywhere there's an n, just like we plugged in a 1 for n right here. So that turns out to be 4 plus 2 is 6 on the top over 4, and you can reduce that by hand, or you can get your calculator to reduce it. Just a quick review of how you reduce a calculator. Any fraction can be reduced like this. Type in the fraction, and instead of hitting enter, hit math, enter, enter, and it'll reduce it for you if you don't want to reduce it by hand. So that's C sub 1. Moving on to the second term in the sequence. Now we're using an n value of 2 there as well as in the denominator. So that's going to be 8 plus 2, 10 on the top, and then 8 on the bottom. 2 goes into the top 5 times, 2 goes into the bottom 4 times. Okay, and then for the third, 4 times 3, and value of 3 this time, indicated by this subscript. And this would be 12 plus 2 is 14. And then on the bottom you have 12. 2 goes into the top 7 times. 2 goes into the bottom 6 times. Okay, and then you might want to just observe the pattern. At this point you've shown enough work. You've shown that you know how to plug in, and you can see a pattern emerging here. Just like there's a pattern here. So, after you do like the first 3 and you actually show the work for that, you can jump to the pattern if you'd like. What's happening in these particular answers is that the numerators are odd numbers beginning with 3. So 3, 5, 7, the next one will be 9. And the denominators are even numbers starting with 2. 2, 4, 6. Okay, and so if you want to just jump right to the answer based off of that pattern, as I said, the numerators are odd numbers, 3, 5, 7. Next one would be 9 in the sequence. Denominators were 2, 4, 6. Next one would be 8, and so on. For the fifth term, next numerator would be 11. Next denominator would be 10. Okay, and those give all the answers for problem number 3. Okay, numbers 1 through 19 all come from section 12.1 on the practice test. This is problem number 4. We move to a different set of instructions. A pattern is given as the instructions go, and it says write down the nth term of the sequence a sub n suggested by the pattern. So you have -1, 1, 3, 5, and 7, and you want to try and come up with a formula that will create these particular numbers. Okay, so you have various choices here. Let's see, let's take a look at what we have. And remember, when you are selecting these answers, you want to make sure that the formula you're coming up with, that you can start with the value 1. Plug it into the formula and generate the values that you see in the sequence here. So the one that would work in this particular case, the number 4 would be A. Because if you put 1 in here, 2 times 1 is 2. 2 take away 3 would be -1. See, this couldn't have possibly worked. I mean, you could have tried any of these. If you were to put, the next value in there. So in other words, when you go to plug in 1 in this particular problem, in that formula right there, 2 times 1 minus 3 gives you 2 minus 3, which is equal to -1. Okay, so that generates the very first value, but by starting off with a value of 1. You want to start these off with a value of 1. Okay, if you were to go and do the next value, then you'd be plugging in this particular n value. So again, 2 times n minus 3, and that should generate the next value in the sequence, and that would be 4 minus 3 is equal to 1. Okay, and that's the next value, and so on. Okay, so let's give the work for that particular problem. Okay, so when you go A sub 1, that means you're going, just like I showed on the previous page, this would be 2 minus 3, or -1. It's the first number in the sequence when you go and you give 2, and you can just make sure that it's working. You know, if it's working for at least 3 of them, it's going to work for all of them. Then if you plugged in 2, it would be 4 minus 3, which is positive 1, so it works for that second value. And then when you plug in 3, it would be 2 times 3 minus 3, which would be 6 minus 3, and you get the next value, and so on. Let me mark on your practice test what the answers were so far. So I already have these indicated on the practice test because I was working them out before I made the video and just making sure all the answers are right. So this particular answer, 0, 2, 6, 4, 12, and 20, that was choice D. Okay, for number 2, where we were getting 2, 4, 8, 16, and 32, that was choice B, 2, 4, 6, 8, 16, and 32 for number 2, so that was B. For number 3, where we did these fractions and then finished it off by observing the pattern, so 3 halves, 5 fourths, 7 sixths, that was choice B. 3 halves, 5 fourths, 7 sixths, and these were the 2 that we got by pattern, so that was choice B. And then this fourth one, we chose this formula right here, 2n minus 3, and that was choice A. Okay, likewise for number 5. For number 5, you're starting off with 4, 16, 64, 256, and 1024, and then it goes on. Okay, so these seem to all be powers of 4. Like this is 4 to the first. This would be a sub 1 because you're putting in a power of 1 here. This would be 4 squared, so it would be the second term. This would be 4 cubed, so it would stand for the third term. So the formula could go like this, that a sub n, the nth, any term of the sequence can be had in this manner by just raising 4 to a particular, oops, I'm not letting you see what I'm doing. Sorry about that. So these were the numbers they gave you. Just notice that these were all powers of 4. So this was 4 to the first, 4 squared, 4 to the third. This is 4 to the fourth, and so on. And so by noting that, you can just see that whatever the n value is, that's what the power should be. And so I wrote this formula here. A sub n is 4 raised to a power of n. And that particular choice for number 5 was D. Moving on to 6. In problem number 6, we have 1 over 1. That's the first term in the sequence. Then 1 over 4. Then 1 over 9. 1 over 16. And 1 over 25. So let's just see where these numbers are coming from. Okay, so you're not taking any one particular number like we were here and raising it to a power to get each of these. I mean, because, you know, what are you going to say? That you could get a 4 by doing 2's, 2 squared, or you could say 4 to the first. So you can't use 2's or 4's to get a 9. So it's not the same base that's being raised to different powers as was the case in number 5. So let's see what we could do here. we could get these all appear to be squares. This is 2 squared, 3 squared. This is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So we could let that value that's being squared, like for instance, when you're getting this very first term, it would be this number squared. When you're getting the second term, it would be this number squared. So this value would be the n value. So these can be written just like this is this 9. Now we're going to have to create, a situation where it's 1 over that number, but that's easy to do. I just want you to see the pattern in the denominator. When you go to do this one, to get the denominator, it will be 3 squared. So we can write a formula like this, okay, and so on. Just noticing where those denominators, because we're just going to say that the top is 1. So the formula can be written like this. Any term in the sequence, which we call the nth term, can be had in this fashion. You can go 1 over the n value, like when you're talking about the first term, that would play the role of the n value, so it would be that value squared. When you're talking about the second term, that would play the role of the n value, because in these problems, the n value is depicted by the subscript. The subscript is the n value. To be 2 squared. So basically that's how you're getting all the values in this sequence. Just 1 over whatever the n value is squared. Okay, and in the particular choices that we had, that was B. Okay, so number 7. I think the directions change at that point. Give me 1 second. Okay, moving on with number 7. Let's see what they want in that problem. I don't know if the directions changed or not. Yeah, it says the sequence is defined recursively. Write the first 4 terms. So it starts off like this, telling you that the first term, they have to tell you what the first term is, and sometimes they have to tell you too, depending on the complexity of the problem, whenever you're going to be writing the terms of a recursive formula. Because recursive means you're using previous terms to find subsequent terms. Times A of the previous term. So to find any term in the sequence, you're going to grab the previous term and multiply it by, this means the previous term. And the a minus n to the 1 is previous to this term. And you're going to multiply it by 3 to get any particular term. Okay, we already have the first term, so the first term we'd actually be looking for ourselves, since we already have the first term, would be the second term. So, according to this formula, it says take the previous term to this, which would be a sub 1, and multiply it by 3. And that would just be 15. Then when you go to get the third term, again, read what this formula says. It says take the previous term and multiply it by 3. Well, now 15 is the previous term. And now it's 3 times 15, 45. Then when you go to get the fourth term, it's 3 times what is now the previous term, which is 45. Okay, and 3 times 45 is 135. And this actually said just to find the first 4 terms. So these are the first 4 terms. The first one was given, and we found the next 3 terms. Okay, so which one had those answers? That was choice C for number 7. Okay, 5, 15, 45, and 135. The one that was given, and then the 3 that we found. Okay, moving on to number 8. Okay, number 8, they give us a sub 1 is equal to 135. And then they say the term after that, in other words, the next term, will be defined in this way. 1/3 times a sub n. Okay, again, this is under the same set of instructions as number 7. It says a sequence is defined recursively. Recursively just means that in order to get subsequent terms, terms that come after the first term, that's what subsequent terms are. You always have to use the term previous, a term that you just got, the immediate previous term, and do something to it to get the next term. So if you want to get a term, I know this is a little bit harder to read because they change the notation on you sometimes, but it still means the same thing. You're trying to get the next term. That's what n plus 1 is compared to just n. N plus 1 compared to n means you're trying to get the next term from the term that came before it. So this notation in this problem represents the previous term. And all of your recursive problems will always be like that. To get subsequent terms, you must use the previous term. So when we go to do a sub 2 in this particular problem, which is the next term after a sub 1, we're just going to use the previous term times 1/3. Okay, previous term, only term we know at this point is 135. So that is the term previous to the one that we are finding. So 135 divided by 3, that's what 1/3 times 135 means. It's top times top, because 135 is the same thing as 135 over 1. So it's top times top, 135 divided by 3. My calculator's not dead. There. 135 divided by 3 is 45. So 45. Okay, then next term, a sub 3 is 1/3 times the previous term. Now this becomes the previous term, and that is 15. 45 divided by 3. Then finding the fourth term, it'll be 1/3 times the previous term, which is now 15. And 1/3 of 15 is equal to 5. And those are the first 4 terms, just like the instructions say for 7, 8, and 9. So I'm sure you've printed off a copy of this, because otherwise how could you attempt the problems? So you can see the instructions for each problem. Okay, so now let's see what choice from the practice test offered these answers. The one they gave us, and then 45, 15, and 5. So for number 8, that was B. The one they gave us, 45, 15, and 5, were the ones we found. Okay, then going to number 9, under the same set of instructions, find the first 4 terms for a sequence that's defined recursively. So they're giving you the first term is 2, and they actually give you the second term, which is 5. And that's because they plan on giving you a recursive formula that uses both of these. That's when they're going to give you more than one value. So now they're saying to get any subsequent terms in the sequence that you should multiply the term that came 2 before the one you're looking for minus 3 times the term that came 1 before the one you're looking at. So I'll demonstrate that here. Okay, so let's say I'm going to find the next term. We already have the first term, we already have the second term. So the first term that we are actually looking for is the third term because terms 1 and 2 have already been given. So following this, it says use the term that came 2 terms before this. That's what n minus 2 means. That would be this one. This is the term that came 1 before the one we're looking for. And this is the term that came 2 before the one we are looking for. So it would be that term minus 3 times the term that came 1 place before the one we're looking for, which would be the 5. So now this would be 2 minus 15, and that answer is negative 13. Okay, so we found that one ourselves. So we have the first, second, and third term. We don't have to go very far here because the directions for numbers 7, 8, and 9 only asked for the first 4 terms. So looking for the 4th term, and then we are done. So following this formula, once again, that uses the 2 values previous to the one we are finding right now. It says start off with the term that came 2 spaces before the one we're on right now. So this is one right before it. This is the one 2 spaces before it. So we're going to go that value first, minus 3 times the term that came 1 space before the one we're looking for right now. So 1 space before would be this negative 13. So that would be 5. This times this is positive 39. And when you add those, you get 44, and that's it. We are done because we actually have the first 4 terms. Okay, moving on to number 10. Problem number 10. Karen has a balance of $1,000 on a department store credit card that charges 1.5% interest per month on any unpaid balance. She can afford to pay $150 toward the balance each month. Her balance each month after making a $150 payment is given by the recursively defined sequence where they're giving you the initial amount. That's why it says B sub 0. It's the initial amount that she owes, and this is how she pays it down. So they've created the formula for you, and it just says for whatever balance you are trying to find. Let's say you're trying to find the balance after 1 month. It's given by, after 1 month, then it would be 1.015 times the previous balance, the balance of the previous month, minus 150. So let's write that here, just so you can have something to follow as we try to reach the answer. So this was the initial amount that she owed. This is the recursive formula that's been created to explain how she's paying this balance down, which is exemplified by that minus sign. Okay, whoops, I think I missed something here. I left the B off of there. So this just means take the balance from 1 month ago and multiply it by 1.015 and then subtract 150. And you know, this extra little bit right here, because if you were just using the balance from the previous month, it would just be B subscript n minus 1 times 1. But this little 0.015 is that 1.5% interest that they were talking about in the actual problem. They're tacking that on to whatever she owed from the previous month. That is why they're multiplying by 1.015, because that 1 gives you the whole balance from the previous month, and then it charges a little extra, 1.5%. It's just 1.5% is written as a decimal here. And then you subtract the 150 that she is plunking down or paying on her balance. Okay, so to get this answer for number 10, it would just be the balance after, you know, the first month would be 1.015 times the previous month's balance, which is just what she owed originally, the $1,000, then minus the 150 that she's paying to bring down what she owes. And then you can just pop that into your calculator. This times this minus 150, and you get 865. Okay, so let's see. I don't know if I chose what answers these were, but for number 8, the choice that had these answers right here was B. And I believe I attached an answer key to your practice test, so you can check that you're getting these answers as you go along. And then in problem number 9, the choice that had these answers, the 2 values that they gave us, and then the 2 that we found, that was choice number C. 2, 5, negative 13, and 44. 2, 5, negative 13, and 44 for number 9. And then this one, 865, that wasn't multiple choice, but that is the answer. And then number 11, let's try that one. All right, so now what we get is different set of instructions. We get this kind of symbol right here, which means they're asking you for a sum. This is the summation symbol. This is the formula that you're going to use to create your sum. You're going to start by using a k value of 1, and you're going to go up to the nth term. Okay, so it just says write out the sum. Okay, so here we go. All right, so allowing your k value to be equal to 1, that would be 3. I'll just write it up here and then I'll write what it simplifies to, just so you can see what the work is. Just be 3 times 1 plus 3. This is when I allowed the k value to be equal to 1. I got 3 plus 3, or 6. And let's see. Instead of putting the commas, I'll put the plus signs, because it is a sum. A sum meaning that you're expressing it with plus signs in between the terms. So this was when I let k equal to 1. Moving to the next one, it would be 3 times 2 plus 3, which means I'm allowing my k value to be equal to 3. So this would be 6 plus 3, or 9. Then the next time I would be doing, I would be letting the k value go up to 3. So here it was 1, here it was 2, here it's 3. And then adding 3 all the way to n, where I let the k value be equal to n. And then it would just be 3 times n plus 3. Okay, so this would be 9 plus 3 is 12. And then this would be 3n plus 3. And you can do that last term so that you're leading up to that formula that you're giving. So just like this, and then you're adding that nth term. Okay, that particular answer was C. 6, then 9, then 12, all the way leading up to the nth term. Okay, number 12. Problem number 12, you're starting off with a k value of 0. And you're going all the way up to, so they'll give you the starter value here and the ending value here. And this is the formula that you're using, 1 over 2 to a power of k plus 1. Okay, and then we're going to write the terms. Okay, so here I go, letting k be equal to 0. That would give me 1 over 2. Let me put this a little bit lower. So you could see me plugging in as well as simplifying it. Okay, so when I let k be equal to 0, that just means I put a 0 right in here. 0 plus 1 is 1. 2 to a power of 1 is 1 half. Okay, 2 to a power of 1 is just 2, so that's my first term. Okay, next would be, I guess I'll just put the plus signs down here. Okay, now I'm going to use the formula again, so now it's going to be 1 over 2 to a power of k. This time I'm going up to a k value of 1, so it would be k plus 1. K plus 1. So that's 2 to a power of 2, or 4. Okay, then I'm moving on to the next one. I need to put my pluses in both places. Now moving up to where my k value is 2. So it would be 2 to a power of k plus 1, which is 2 to the third, or 8. And then I'm going to go all the way to 1 over to the nth term, so it would be 2. So that means I'm letting my k value spin all the way to n. So it would be 2 to whatever your power of your k is, 2 raised to a power of k plus 1. But my k value is n, like that. So if you just want to give this in a little cleaner way, it's 1 half, 1/4, 1/8, and then you just go with dots and showing that that last fraction is written like this. Just writing it a little bit more neatly. And that particular answer, oh wait, they told me to go up to n minus 1, not to, sorry about that, to fix that. Okay, so I was supposed to be going up to n minus 1. So k equal to n minus 1, which means that this should have been 2 to a power of k. They said that that k value should go all the way up to a maximum of n minus 1. So put that in for the k value, and then add that extra 1. Okay, so that would have made my last fraction, my final fraction, n minus 1 plus 1. Those the negative 1 and the positive 1 would cancel, leaving me with just 2 to a power of n for my last term. And let's see what answer that was. That was choice A. We got a 1/2, a 1/4, we got a 1/8, and then when we let the k value go all the way to n minus 1, the negative 1 and the positive 1 canceled, leaving us with this as our last fraction. Okay, that takes us all the way to number 12. Okay, we're still in section 12.1. They go all the way up to number 19. Okay, so now we're on number 13. Let's see what kind of problems those are. And we're still in the same set of problems. Okay, so we still have a summation. It says start at 1 and go all the way to a value of n for your final evaluation. And then this is the formula you're supposed to use. Okay, so if I start off by letting the k value be equal to 1, well then that would be 1 squared over 4. Again, I wrote that too high. So I want to show you me plugging in and then what I get afterwards, so just so you can follow it later. So just 1/4, and this is when I allowed the k value to be the starter value right here. This is a summation, so you can put the plus signs. So now I'm going to let my k value be 2, which means I'm just doing 2 squared over 4. So 2 squared over 4, that's 4 over 4, or just 1. Okay, and then I'm going to the next one. This time I'm going to let my k value be 3. So then that would be 3 squared over 4, just continually using this formula right here. So that would be 9 over 4. Okay, and then we're going all the way to allowing the k value now to be n. They said to end it at a k value of n. So then it would be n squared in place of the k value over 4. And that's it. All right. Let's see what answer this was. 1/4, then a 1, then a 9/4, then n squared over 4. And that would be a 1/4, then a 1, then a 9/4, and then n squared over 4, just like we got. 1/4, 1, 9/4. So that was choice A for number 13. Okay, moving to 14. In 14, it says express the sum using summation notation. So they give you a sum. They show you a sum of 3 to the 5th plus 4 to the 5th. And you're going to try and come up with a formula so you can write this in summation notation. They went all the way up to 8 to the 5th. So go like this. Your k value is going to start with a base of 3. The power of 5 just continues on every one of these bases. The bases go from 3 all the way up to 8. So we're starting at 3 and ending at 8. And the formula that produces each of these values would be k to the 5th. So it would be 3 to the 5th, then 4 to the 5th, then 5 to the 5th, then 6 to the 5th, then 7 to the 5th, then finally finishing with 8 to the 5th. Starting at 3, escalating all the way to a maximum value of 8. Those values always being used right here for k. And that was choice A. What number is this? 14. Number 14, that's A. Right there. And moving to 15. In 15, they give you 1/3, 1/2, 3/5, and then it ends with 5/6. And let's see. Hold on for 1 second. So I'm looking. A problem like this, I would probably just, make it multiple choice for you just because it's easier to see what's going on here. I think the difficulty, that students have with this problem is that they don't realize that some of the answers in the sequence or in the summation, I should call it that, the summation, that they've already been reduced. And so it's kind of hard to come up with a formula that exemplifies the pattern. So it makes it a little bit easier if I make this specific type of problem multiple choice. But the one that works here out of the choices that you have is this one. Let's see if you can follow this all the way up to 10. And the formula would be the k value as the numerator, but a value that is 2 higher in the denominator would actually give you all these fractions. And let's check that out. If you were to use 1 for the k value, it would be 1 over 1 plus 2. And that would give you the 1/3 that you're seeing in this position. Then if you were to, okay, so this is for k, I'll move this down just so it's a little bit neater. This is when I used k equal to 1. So I put a 1 in there and a 1 in there, and I ended up with 1/3. So that was that first value. And then when I let k be equal to 2, then it would be 1 on the, it would be 2 on the top, because the formula goes k on the top, k plus 2 on the bottom. And then it would be 2 plus 2 on the bottom, so 2 over 4, which is 1/2. So it is 2 over 4, but then they're reducing to get this next value in the summation. Then if you were to let k be equal to 3, then it would be 3 on the top, and that same k value with 2 added to it on the bottom, and that would give you 3/5. And that's that third value then you're seeing. And then you're going all the way up to where the k value is 5. And it looks like, I mean, that, like I said, it's a little bit hard to figure out that some of these fractions have already been reduced. So you may think that you need to stop this at k equal to 5, because it looks like you're going up to about, it looks at, when you look at this fraction, it looks like you're going up to a value of k equal to 5. But what if that 5 came from reducing a particular fraction? So you actually might be going way higher than a k value of 5. So you have to think to yourself, what reduces to 5/6? And you might start with, some really easy multiples of 5 over 6. Like if you were to multiply each of these by 2, you would get 10 over 12. Is it possible that they went to that, all the way up to a k value of 10? Because the top is the potential k value. So did they potentially go this high? We could also try other multiples of 5 over 6, like multiply this by 3 and by this by 3 and see if that's what they went up to. Because look at this. If you're thinking that they went up to a k value of 5 just because you're seeing a 5 here, well, think about it. If you were to plug that in here, you think the k value is 5, the last one. That would mean you'd have a 5 here, but then 5 plus 2. If you plugged in a 5 here, 5 would go with 7. So that is not how they got this 5 over 6. The denominator is not what it should be for a k value. So that means they went beyond the k value equal to 5. They went further. Would this work, which is really equivalent to 5 sixes, it's just not in reduced form, but these are equivalent. So think about it. If you used a k value of 10, is that possible? Could the k value potentially be 10? If you were to use a k value of 10, would you get this? Put a 10 here and a 10 plus 2 here. You would get this 10 over 12, and then when you reduce it, it would be 5 sixes. So that is exactly what they did. When they have fractions in the problem, you have to consider what they may be in their unreduced form. So this went all the way to a k value equal to 10, which would give you 10 on the top and 10 plus 2 on the bottom, which reduces to 5 sixes. 10 over 12 reduces to 5 sixes. Divide by 2, and you get 5 sixes. So when you go to write this summation formula, you see why they went all the way from 1 to 10. Okay, and that particular formula was choice B. Okay, that's number 15. And number 16. In 16, they give you a sequence. Again, you're doing a summation. Summations can have pluses or minuses in between them because it is possible that you'll be adding a negative number. So a negative number is, when you're adding a negative number, it's going to appear just as a single minus sign, which is what you're seeing in this problem. Okay, so 64 over 125. It finishes like this. When they put a -1 out here, it's to have the signs alternate. Positive, negative, positive, negative. That's what makes them alternate like that, this -1 here. And then it goes like this. This base is 4 over 5 because look at the numerators. The numerators are 4 to the 1, 4 squared, 4 to the 3rd. Whereas the denominators are 5 to the 1st, 5 squared, 5 to the 3rd. And then there's a little 11 right here. Okay, so they're going all the way to a power of 11. In the sequence that they're giving you. So let's see, what can we do with this? All right, now if we're going to start with, let's say we were starting with every single one of the answers that you've been offered here, start with a k value of 1. So how do you start with a k value of 1 and allow it to come out positive as you have right here? So it would have to be, for this particular problem, We're starting off with a k value of 1. We're going all the way to a k value of 11, because the powers that you're seeing are the powers that they're raising the top as well as the bottom to. For instance, this is 4 to the 1, this is 5 to the 1. So the power plays the role of the k value. This is 4 squared, so the k value would be 2. This is 5 squared. This is 4 cubed. This is 5 cubed. So they just said it like this, that the base is 4s are being used on the top, 5s are being used to the bottom, but they're both being raised to the same power to get every single one of these fractions. And so why not just say the power one time? That power applies to the top as well as the bottom, and that's how come I knew they were going to 11, spinning it all the way out into 11. Okay, then for the rest of this, again, I want to concentrate on the fact that this very first fraction is positive. We have to somehow make that positive while using this particular formula. This -1 is what makes each of these terms come out either negative or positive. We want the first one to come out positive. So imagine if I was to say, okay, let that be the power on the -1. Well, when k is equal to 1, that would make that very first fraction come out negative, but yet it is not supposed to be negative. So I am going to let the power on the -1 be k plus 1. So that when I go to do that very first value, I put a 1 in there. 1 plus 1 is 2. -1 to a power of 2 is a positive number. -1 raised to a power of 2 after me plugging in this 1. I would get a 2, and that would be a positive. And then the next one would be negative, because they're going to alternate. Then this would be 4/5. But you want the power on this to just be k. Let's see if this works for these particular 3 values. Okay, so if I was going to let my k value be 1, and I went -1 to a power of k plus 1, k plus 1, and then I went 4/5, but instead of using k plus 1, I just used k. Then that would be a power of 1. Would that get me the very first fraction that you are seeing here? Well, 4/5 to a power of 1, yes, it is 4/5. -1 raised to a power of 2 is just positive 1. Anything raised to an even power is positive. So this would be positive 1 times 4/5. Yes, you do get the proper value of 4/5 for that first term. Moving on to the next term. Let's make sure it works for these 3 terms. So then it would be -1. We're working on k equal to 2 now. So it would be -1 raised to a power of k plus 1, which gives you -1 to a power of 3. -1 raised to any odd power is negative. So it's negative. And then you have your 4/5, and the 4/5 is just being raised to a power of k, whatever k is, without the 1 being added to it. So that would get you 16/25, which is exactly what we're supposed to have for that second term. So that worked out. This worked out. Let's try it one more time. -1, we're using k plus 1 as the power. So right now we're on a k value of 3. This would be 3 plus 1, or -1 to an even power, which is positive 1. This is how you make your signs alternate, by using -1 to an alternating even odd power. And the only reason I chose to start with an even power, which is how I knew I had to use k plus 1, is because I wanted the first term to be positive, and it can only be positive if we start off with an even number as the power. So here I'm on 3, it's -1 to k plus 1, and then 4 fifths to a power of just k. So that would be 4 to the third and 5 to the third. 4 to the third is 64, and 5 to the third is 125. So you'd have positive 64 over 125. That term would be positive, just like you see here. So all three of those worked out. So that's your formula right there. You're starting off using 1. You're alternating that negative, positive coefficient, and the power on this has to be 1 less than that. We wanted that to start with an even number. So that choice is, let's see, B. Right there, -1 to a power of k plus 1, and then 4/5 to a power of just k. Okay, that takes us to 16. Okay, this is the last one I'm going to do in this video, and then I'll continue in the next video. Okay, so let's see. For number 17, let's see, it might be the same instructions. It says find the sum of the sequence for number 17. So I would just do this one by hand just because it's only a few terms. They give you this formula, -1 raised to just power of k, and then you're multiplying it by -9 times the k value. You're going to let the k value start at 1, and then they say to let it go to 4. So since you're only doing a few terms in the sequence, I would just do them by hand. So when I let k be equal to 1, that means I'm going to have -1 raised to a power of 1 times -9 times -1. And I'll put my values down here. So this would be +9 times -1. -1 raised to an odd power is -1. So -1 times +9, this is +9, this is -1, and you're multiplying. So this is the first term in your summation. Then, for the next one, you're going to let k be equal to 2. So that's going to be -1 raised to a power, sorry, I'm not showing you again. This is -1 raised to a power of k, and this is what I did for my very first term. I went -1 raised to a power of 1 because I was doing the first term. And then the formula goes on to say times -9 times your k value. So all of this was my first term. So 9 times -1 gave me this -9. Now I'm on my second term. So it's -1 raised to a power of k times -9 times k. And we're using a value of 2. So this is going to be -18 times -1 squared. -1 to an even power is just +1. So 1 times -18, -18. Okay, then next one is -1. Now we're on k equal to 3. So that goes there, and then it's times -9, and we're using a 3 right here. So this gives you -27 times -1 raised to an odd power is -1. So -1 times -27 is +27. And then I have to do one more. I'm going to have to squeeze that in right here. It'll be -1 for my fourth term. So I just did the third term. Now I'm doing the fourth term. -1 raised to a power of 4 times -9 times 4. Okay, this is me doing my fourth term where the k value is equal to 4. -1 raised to an even power is +1 times negative 36 gives you negative 36. So when I add all these together, I will find the sum of the 4 terms produced as we let k spin from 1 to 4. Okay, so just pop those in your calculator. And let's see. I think I have a mistake here. I do. This was supposed to be positive 1 right here. I plugged in a negative 1. So this should have been for the first term, negative 1 raised to the power of k, which was 1, and then times negative 9 times the k value. So that should have been positive 1 right there. So this should have been negative 9 for this, times negative 1, so that should have been positive 9. Just wanted to check the signs on that. Now add all of these up. Okay, 9 minus 18 plus 27 minus 36. 9 minus 18 plus 27 minus 36, and you get negative 18. Okay, so I know the answer for this one was, let's see. Oh, that was a free response. And yes, let me look that up. Yep, the answer is negative 18. So that's correct. All right, moving on to numbers 18 through 30. Those will be in the very next video. So this first video covers 1 through 17.